I'm going to discuss the U-substitution method. The U-substitution method is a method to calculate antiderivatives, also known as indefinite integrals, as well as definite integrals that involve compositions of functions. Okay, that's a lot of words, so let me write down the basic pattern that's involved here. Okay, there's actually two formulas, two patterns that I want to focus on. Suppose that I wanted to calculate the following antiderivative. Now, I hope that antiderivative reminds you of the chain rule. Let me write out what the chain rule would tell us is the derivative of the composition of f and u. That would give us f prime of u times u prime of x. So as you can see, the antiderivative that we're looking for is the right side of that blue equation. Or one antiderivative is the right side. So the general answer is f of u of x plus the constant of integration. Okay, and the corresponding pattern for definite integrals would be the following. Now, assuming that the antiderivative technique works, we can write the definite integral as f of u of b minus f of u of a. Okay, and let me make one more comment. Notice that the definite integral that I wrote is equal to the following much simpler definite integral. Okay, what would the green definite integral evaluate to? Well, the antiderivative of f prime with respect to u is f of u. Okay, and then we evaluate at the limits of integration that I've written there. So you can express your intention of finding the difference of antiderivative values with this bracket notation that I've just written there. Okay, if you haven't seen that before. So that would give f of u of b minus f of u of a as the answer. Now, why is that interesting, useful, or relevant, since it gives the same answer as the definite integral formula that I already wrote down? Well, because notice that, first of all, the green, what you can do sometimes, what I'm getting at, is if you have a complicated definite integral, you can rewrite it in a simpler form where you don't even have to worry about the variable x anymore. Okay, notice I never wrote x in green. Okay, that's the advantage of this slightly different way of working out the answers. You could move to the u variable and disregard the complexity of writing everything in terms of the x variable. Okay, so make a note of these patterns. We're going to use them now in several examples. Okay, here we go. Suppose we wanted to calculate this definite integral. Okay, so for this, what I would do is I would interpret f prime of x as being equal to the cosine of x. I would interpret u of x as being equal to 2x. That would imply that f of x is equal to the sine of x, and u prime of x is equal to 2. And lo and behold, the original definite integral that we're interested in is an example of the patterns we were just discussing. Okay, so then the answer is the sine of the difference of the difference of two values with respect to the antiderivative of the sine of 2x. Let me write what I just said with that bracket notation I was talking about. So this apparently is the sine of pi over 2 minus the sine of 0. That is 1 minus 0, or 1. Okay? And let me also, just to convince you that it would work, let me rewrite the original problem in the much simpler way as the cosine of u, the definite integral involving a cosine of u, I mean. And so for the new limits, I'm going to use 0 and 2 times pi over 4, so that's pi over 2. So that'll give the sine of u, or I'm going to evaluate a difference involving the antiderivative, the sine of u. So that would give the sine of pi over 2 minus the sine of 0, and lo and behold, we get the same answer without needing to use the x variable. Okay? Now, one concern you may have is, how do I know what to define the f prime function as? How do I know what to define the u function as? Notice there's only so many possible choices. Okay, there's not that many pieces in the integral I'm trying to solve, is there? Okay, so trial and error is perfectly fine. If there's 2 or 3 possibilities, quickly try all of them, and you will soon enough stumble upon the right choice for the f prime and u functions. Okay? Now let me do one more example, and then I'll have you do some exercises. So suppose I wanted to calculate this definite integral. Okay, so once again we quickly try all the possible choices for the f prime and u function, and there's not really, again, many possibilities here. For f prime of x, I'm going to go with x squared, and u of x has to be the quote-unquote inner function of a composition. There's only one composition in this problem, so it has to be 3x plus 1. Okay, so that implies that f of x is x cubed over 3. U prime is equal to 3, and this integral, this definite integral, does not follow the pattern that I'm trying to use in this video. Why doesn't it follow the pattern? Well, there's no coefficient of 3 in the original problem to correspond to the u prime. All right, so now what do? Well, let me change the appearance of the original integral so that it does follow the pattern. Okay, I think you would agree that I could multiply any quantity by 3 1/3. Okay, both of those numbers at the same time, and I won't change the quantity. Furthermore, I think you would agree that I could write the coefficient on the to the right or left of the integral symbol, and it won't change the answer. Okay, so let me go ahead and take advantage of what I just said. So I could write the original problem as in this way, and the answer wouldn't change. However, by writing it in that equivalent format, now I can use the pattern that I'm focusing on, the use substitution formula, the use substitution pattern, whatever you want to call it. All right, so now we can work it out. And so 3x plus 1 over 3 cubed, we're going to evaluate it at 1 and 0 and find the difference. So let's see. Let me first simplify. 1/9 3x plus 1 cubed. Evaluate that at 0 and 1 and find the difference. So if I evaluate it at 1, I get 4 cubed over 9. Evaluate it at 0, I get 1 cubed over 9. So 64 minus 1, 63 over 9. Apparently the answer is 7. Okay? And using that technique, slightly different technique where we rewrite the original integral in a simpler form would have given us this. The integral of u squared with respect to u from 1 to 4. Okay, look how much nicer that looks. Okay, I think you would agree that that's a much nicer integral to do than the original one. But nevertheless, we'll get the same answer. U cubed over 3, evaluate that at 4 and 1 and take the difference. 4 cubed over 3 minus 1 cubed over 3 gives 7. Okay? Now I'd like to have you do an example. Would you please, using what I just talked about, find the definite integral from 0 to 1 of the square root of 8x plus 2 with respect to x. Okay, pause the video and work that out, please. Okay, so now I will do it. So the f prime that works the best is, the definition of f prime is f prime equal to the square root of x, and then u of x, a good choice, probably the only choice I can think of, is 8x plus 2. And that would imply that f of x, now taking the antiderivative of x to the 1/2 gives x to the 3/2 divided by 3/2. And I can rewrite that as 2/3 x to the 3/2. And u prime of x is 8. And this is one of those examples where I need to multiply and divide by some coefficients to make it fit the pattern. So if you do that, you will have 1/8, and then the antiderivative you'll end up with is 2/3 of 8x plus 2 to the 3/2. We're going to evaluate that at 1 and 0. Okay, let me simplify. So 2 over 8 times 3, 2 over 24, 1 over 12, 8x plus 2 to the 3/2 divided by 12, evaluated at 1 and 0. Okay, let me work that out at the bottom of the whiteboard. So if I plug in 1, I get 8 times 1 plus 2 is 10. So 10 to the 3/2 over 12 minus what I get when I plug in 0. That'll give me 2 to the 3/2 over 12. And maybe you want to factor, take out the common factor. So probably the most compact way I can write it is the following. Okay, and I hope you got an answer that is equivalent to that. Okay? Now, let me have you do one last example. So, find this definite integral from 0 to pi over 2. Okay, so pause the video and try to work out that one, please. Okay, so I'll go ahead and work this one out. So f prime of x is equal to cosine of x, and u of x is equal to x cubed. So that implies that u prime is equal to 3x squared, and f of x is equal to the sine of x. And this is one of those situations where we have to multiply by 2 coefficients to get it to match the pattern. Okay, so let me do that. Actually, let me solve this one using the slightly different method that gives you that much simpler integral. Okay, so first I'm going to multiply by 1/3 and 3. Okay, then I'm going to switch to the variable u, and I'm going to get 1/3 the integral of the cosine of just u, evaluated at 0 and pi cubed over 2 cubed, or 8. All right? So let me work that out at the bottom of the whiteboard. So 1/3 times the sine of u, evaluated at pi cubed over 8 and 0. And that gives 1/3 the sine of pi cubed over 8 minus 0, minus 1/3 the sine of 0, which is 0. So putting it all together, we get simplifying, we get 1/3 the sine of pi cubed over 8 as our final answer.